Good morning, teachers. I'm Prannaya, and with my teammates Pincher and Francis, we present to you our CM5131 practical project, which we have tentatively titled The Classification of Drugs via Simple Chemical Concepts. So, our task, as highlighted in the practical sheet, was to identify four different molecules, namely paracetamol, ambroxol, aspirin, and loperamide. These were found in the form of drugs, and we actually did ground them up into small pieces so that we could conduct our experimentation. So in our experiment, we conducted three tests to empirically identify which of these were paracetamol, aspirin, ambroxol, and loperamide. So starting off, we did our first test on acid-base neutralization, in which we basically added 2 cm cube of sodium bicarbonate, aqueous sodium bicarbonate, to one spatula of each sample in separate test tubes. So ideally, the reaction that should be formed is that of aspirin, which, as you may notice, has a carboxylic acid group, which can actually react with the sodium bicarbonate to produce sodium 2-acetoxybenzoate, which is this molecule right here, and it will also eliminate CO2, which is pretty much what will be observed in the form of effervescence. So as you can see, we did conduct our observations on all four templates. So this would be tablet 1, tablet 2, tablet 3, and tablet 4. So as you can see, there weren't many observations made in most cases, but we did observe a glaring amount of effervescence in tablet 3. Hence, we were able to determine that tablet 3 was aspirin, and from there, we simply checkpointed it as aspirin and didn't conduct any more tests on it so that we could continue with the rest of our observations. From there, um, we conducted the second test, which was oxidation. In the case of oxidation, what we did was we added 10 drops of acidified KMNO4 to one spatula of each sample in separate test tubes, similar to what we did with sodium bicarbonate. And when we thoroughly mixed it, it's important to thoroughly mix it because the results may not be immediately apparent. So the ideal reaction, which is no reaction, would come from loperamide, which, as you may have noticed, has no hydrogen atoms at these two atoms, which means they cannot conduct side chain oxidation. And on the other hand, it has a tertiary alcohol also caused by the lack of hydrogen atoms here, and an amide group, which cannot be oxidized. From there, we conduct tertiary results, and as you may note, aspirin has been checkpointed. So as you notice, when we first added the KMNO4, the results weren't apparent. And in the case of tablet B, we noticed it becoming brown instead of colorless, while tablet 1 really did decolorize quite efficiently. Tablet B's change in color to brown is likely due to the fact that it didn't oxidize completely, and hence it was left in its MnO2 state, which is in this case brownish in color. So in the end, these were our observations. We observed that purple KMNO4 either changes color to form a continuous colorless or orangish brown layer. On the other hand, tablet 4, which was the odd one out, left purple KMNO4 as constant. It didn't change any color of it. So we can then determine that tablet 4 is loperamide, and from there we checkpoint this as loperamide, similar to what we did with tablet 3. From we conduct our last test, which is the ferric chloride test. This test is actually in chapter 4, so this has been recently introduced to us, and hence it may be a bit unclear as to how it works. So basically, what we do is we add 2 cm cube of aqueous ferric chloride, which is iron 3 chloride, to one spatula of each sample in separate test tubes. From there, we are able to observe this result in paracetamol, which has a phenol group which can react with the ferric chloride to form this violet complex and hydrochloric acid. So we did conduct our results, both of our tests on these two samples specifically, And as you can see, the results were quite apparent from the start, since there was no change in color here, and this changed to form a dark violet compound, which was exactly what we needed. So hence we were able to then determine that this is paracetamol and this is ambroxol. And from there, we can now checkpoint and finally conclude our results. So in the end, the conclusion was as follows. We concluded that A or tablet 1 was paracetamol, tablet 2 or B was ambroxol, tablet C or 3 was aspirin, and tablet 4 or D was loperamide. In the end, we had this identification table. So this is our final results, and I hope you enjoyed the video. Thank you for watching, and we hope you enjoyed. Thank you.